What's up, guys? It's FF here. No, it's been a long time since I've uploaded, but I've been busy with college classes and everything, so I'm going to try to make a quick, short tutorial for you guys in SFML on how to get a game up and going. So I'm just going to scroll down right now. My other video shows how to get SFML set up. So if you don't have SFML set up or know how to set it up, I would suggest watching the video I got for that specifically. And anyways, after I have it set up, I have created a render window here, and as you can see, I named it Frozen Fire, and I got it full screen, and I just went ahead and set the frame limit to 120 by using the window.setFrameLimit command. My Windows name is window. Created an event, a basic while loop where a game's going to be loading in right here while window is open, and I did the event. I did window.pull event and then plugged in that event I created, and if the event type is equal to close, then close the window. And I also did where if the escape key is pressed, that also closes the window. And here's the clear, and here's the display, and right here is where we're going to draw our objects. So if you have to pause this to look at it for a minute, just go ahead and do that, but I'm going to go ahead and get started by, I'm going to add me a new class completely. I'm going to name this player. And now, because the way I set mine up, player, it never goes into my folder. I'm going to go ahead and drag this in here. Alright, so what our player is going to need is in the header file, the player header file, we're going to include SFML graphics. Any of the stuff that I'm doing here could be done with a sprite as well, but I'm just going to use rectangle shapes just for this purpose. So here's the class. I'll go ahead and put public and private here. So I'll say SF rectangle shape M shape. The M just means member, which means private. And we're just going to name it like that because it's private, because it's good to practice conventions. SF vector 2F, and we'll name this M pause for position. What else do we need? We need we're actually going to use we'll use a float move speed. And public, we'll need an update function. Knew I was forgetting something. Void update, we'll go ahead and need that. Then we'll need a boolean here for M move left and bool M move right. But what we'll do is we'll go ahead and set these to false. In release mode of a game, you guys may not know this, but I experienced this firsthand. If you don't initialize your variables to begin with, they may not be initialized to like false or true or whatever you want them to be, so it's always better to explicitly set them. Alright, now we'll need a constructor for the player. That'll be public. And we'll just take in a float for that. But honestly, I think it could be an int. Be good enough. Int plus y. This is just going to be where we initialize our player. Alright. So let's open up the CPP file for it. Now we'll go ahead and type in player, pause x, and pause y. Now all we'll do is npause.x equals pause x, and npause.y equals pause y. That way we can initialize our player in the code and have him where we want to set him. Next, what we'll do is we got to create the size. So we'll put m shape dot size, set size. We're going to set this to, see, it takes a vector 2, so sf vector 2. Set this to 64 by 64. So why not? Alright, m shape. Set fill color, and we're going to set this to SF green. So why not? SF color green. And then we're going to set the outline color to SF color white. And then let's see, m shape dot set outline thickness. Without setting this, you won't be able to see your outline. We'll just set it to 1 pixel. Why not? That'll be good enough. That's how thick it'll be, and you always have to set your size on your object or you're not going to see it because it's going to be 0. Alright, so that's that. So now all we got to do is we'll go back to our main and make sure that we get it initialized, and right here under the window we'll include our player for one, our player header file. Alright, now we'll go player P, and we'll put them in the middle of the screen, so 1920 divided by 2 because that's just the resolution I'm rocking. 1080 divided by 2. But that's not going to be the final spot. This is just to get us started. Also, we need to have a SF rectangle shape function called getShape. After you create that, we're going to go to our player function. We're also going to go ahead and put our update function. We're not going to use it yet, but we're going to definitely create it. I hit the I know what's wrong. Didn't put void here. Alright. So now we'll do our SF rectangle shape player, and then we should see our getShape function. We'll put return m shape, so this way we can get our shape for when we want to draw it. So now all we need to do is put window dot draw, and we'll just make sure everything's working. P dot getShape. Now if everything works, our player should be in the middle of the screen. And he's not in the middle of the screen, and that's okay. Halfway okay. Oh, I know why. I know why. I think I know why. I know why. Alright. So now we got to go to our m shape dot set position in our constructor. It's been a minute, and we'll just set it to our m pos. Now that works. Now we should be in the middle of the screen. That's why I like doing these live. You can see some of the errors you may come into. So now you can see we got our shape here, and now we can hit escape. Now we're going to create the well, shoot, we'll go ahead and do the movement while we're here. We're also going to, we're not going to add the time yet. We'll add the clock in a minute. So we'll type in let's see, an if statement, if input, or if SF keyboard is key pressed, SF keyboard A, make sure it's capitalized, and we'll say m moved left equals true. else m move left equals false. This is the way that they recommend to do it in the documentation, how SFML works best. So that's the why I do it this way. Is key pressed, SF keyboard. Now we'll do D. Make sure it's capital. And M move right equals true. Then else M move right equals false. See, did we create in our header file? We got move speed. We'll just put this equal to, like, it's gonna be way too fast right now. I'll just put it to 500, but it won't be that fast when we get done. So now I'll just put if m move left, then I'll say mpos.x minus equals move speed. Then we'll say if m move right, mpos.x plus equals move speed. Alright. So let me see, is there anything else I need to do? Yeah, there is actually. And also in this update function, we need to put mshape.setPosition, so at the end of it, it always sets it to our mpos variable. And to make sure players getting updated in the main function right before the clear, we're just going to type in P for our player and then update. Now when we play, we should be able to move our character around. It's probably going to shoot off the screen instantly. Yeah. Probably can't even see this on the camera, but or in the video, but yeah, it's moving really fast. But to fix that, because everybody has different frame rates and stuff, what we'll do, everybody's got different hardwares. This is good practice here at the top. We're going to create a SF time variable called game time, and then we'll create a clock. I don't know why I always do the SF clock variable, and we'll call it game clock. Now while Windows open, we're going to say that game time plus equals, actually I'm going to rename this variable to delta time. Delta time and it's going to be equal to game clock dot restart. Alright, in our update function here, we're going to make it take a it's going to show an error right now, but we're going to make it take delta time, and we'll move back over to our player header file. Our update function, we're going to put in SF time. I'll just name it DT here, and then our update in our main function or CPP file, we gotta make sure it has a time variable as well. I'll just name it DT is here. Now here's where the magic happens. We'll now take that delta time that we're plugging into the update function and we'll multiply it by our move speed here, and we're gonna have to put as seconds as well after it. So after DT, we'll put dot as seconds, and remember to put your parentheses after. And that should get rid of the errors. Now, no matter what frame rate you're running at, it should move consistently above on all platforms, regardless if you're running at 30 FPS or 60 or 120. It'll move the same amount now. Alright. Now we got that done, we're going to create our tile class. This is going to be fun. So go ahead and right click, add new class. We're going to name this floor. I'm just going to name it floor. And because I keep my stuff in a folder personally, I gotta put mine in the same directory as everything else. Alright, header now. Let's see. Private, public, or no, private. They got me all messed up. It's gonna go public first, then private. We need an M shape, or SF. Haha. I hate having to do this. Include at the top, we're gonna add our SFML graphics. I just can't hit the right button when trying to do it under pressure. There we go, our graphics file. Now we should be able to get our rectangle shape. Name it M shape. Also, I'm gonna have to add a function called SF rectangle shape. Get shape. Trying to think right now what else I need. We also need a constructor. I believe so. Alright, now let's go to our floor CPP file. On this also, it's going to take in an integer x and an integer y, and our constructor, of course. Now that we have floor, we'll type in just int x. This is basically going to be where you want it to spawn. See if I can figure out what I'm going to do here. Alright. We're also going to give it a, well, no, I don't even need the, well, actually, I probably will. Just in case, we're going to create a private SF vector2 f called mpos. This is just to be safe. I don't even know if I'll need it. Thinking off the top of my head, so we'll just add it in. If we don't need it, we can get rid of it. Alright, so I'll say mpos dot x equals int x, or equals x, excuse me, sorry about that. Mpos dot y equals y. And now we'll do mpos, here we'll do the shape. Set position. This will be easier this way anyways, the mpos. Yes, I think that will come in handy. Alright, and on the constructor though, because we're going to be calling multiples, because we're going to create an array, we also want to set the size of it though. Set the fill color first to SF color red. We're going to go with red. M shape dot set size to SF vector 2f. We're gonna go with 64 by 64 on this as well. M shape dot set outline thickness. That's a little bit out of order. To 1 M shape. That's that outline color to SF color white. I don't know why this is like that. Make sure it's capital. Alright. So we got the size of both these. The fill color red, outline thickness 1. SF color white. Alright, and we set its position there. I think on that's as much as we have to do for now. So now we can include it in our main function at the top. Include floor. And what we'll do here is we'll say floor F. Make sure it's that. Make sure it's the right one. Alright. And it needs a position. I'm going to go ahead and create a few variables. Floor count equals, how many is it going to take? We'll start off with 25. Right now, I'm just going to put this at 0, 0. Just for now, I may have not even needed that in the constructor. Alright. So now we'll write a for loop for int I equals 0. If I is less than floor count, then we'll say I plus plus. Oh, I didn't mean to put that like that. I plus plus. Alright. And now actually, now that I think about it, we definitely, that constructor is just making things harder, so we don't need, let's say we don't need that, we probably still need that mpies, but we definitely don't need this constructor. What the heck am I doing? I need the constructor, I don't need the variables on the inside. It's been a long day. So actually, to make things a little bit easier now, we're gonna go ahead and move this up to public, and I'm just putting it as pi since it's no longer a variable like that. Alright, now that we did that, we changed our set position to pies. Because having a constructor is just going to make it harder to create an array. So now we're creating an array of this, and we're going to make it, and I think we need to make this a constant. And that way we can use it in an array. We'll make it the same as floor count. That way we'll have the same 25 tiles. And the array will hold that. Alright, so it'll be if I dot set dot pies dot x equals, let's see, what we'll do here is we'll create a start pies. We'll make it 0. So we'll put it to start pause, and then we'll put its position y to the y. We're not going to worry about the y changing, but the x is going to change. So let's see. We don't want to set it at the very bottom, and it's 64, and it starts at the top, so I'll pull out my calculator. We'll just do this the easy way. So the tile 64 plus the outline 65, so we'll do, let's see, 1080 is going to be the very bottom, so we'll do 1080 minus 65, so we'll set this at 1015. And now we'll do start pause dot x plus equals well, actually start pause isn't an x. Alright, so start pause is gonna plus equals, not even 25 either. I'm tripping. So they're 64 plus the outline, so 65 with the total on that. Alright, so the x should go 0 and then go across every time until we get all 25 drawn, and the y should stay the same. And just to make sure that that's right, we're going to go here to our draw, and we're going to put another for loop. And I equals 0 if I is less than floor count, I plus plus. And we'll say window dot draw. Let's say floor. Or it's actually f, and we're going to have to add a function to did we actually add get shape to our floor already? We haven't defined it yet, but we did add the function. Alright, so back here in our floor function, we're going to type in SF rectangle shape floor get shape. Make sure I put it right in there as well. I did. Alright, now all we gotta do is return the shape. And because this is an array, this is just going to be the way the function looks. That's just all it is. Alright, we'll see if it worked properly. Halfway worked. Well, because of this, I don't think that that's going to work exactly. Not going to work that way anyway, so we're also going to have a setter function in our floor for the way that we're doing it. So go back to our header file. Glad I can show you guys this on the spot. So this will actually be void set position. Alright, so now we can go back to our CPP file and we'll type in void for set position or set pos. And we'll just say pos. We'll get an M shape dot X. M shape, actually set position. Let me see the way I'm doing it. And the way we're going to have to do this, unfortunately, is we'll have to carry in an X and a Y. Alright. Now I'll make sure that they're here. Alright, so now when we go back to our main file, now that we have that function set up, for real, I don't even have to do it this way. Well, actually I could do it this way, either way. Well, it doesn't make any sense because I have because the way I have it set up. So alright, so we'll type in fi dot set pos to, let's see what the X is going to be. What did I say it was going to be? Well, it's going to be a 0. Or no, actually it's going to be start pos. Alright, because I already initialized it to 0, and Y is going to be, what did I say, 1015. Then we'll add it. We sure are having a rough time getting this to work. Let's see what's going on. We got 25 of these here. Alright, so this does set the position of that shape to the X and Y. So it should be increased by 65 every time. Show you how to do a little bit of debugging. We're just gonna see how many times this runs. I have IOStream included in mine just for debugging purposes. And we can see that the code is running. But we still don't know why the start pause is not increased. Put it to 1, that way it would fit on the screen. Was it something to do with something to do with my constructor? Shouldn't be. What we'll do is we'll figure out the start position number. Doing a little debugging here. Doing the new line's a little bit more performant than doing the STD end line. Alright, so it is increasing. Yeah, I don't understand. That's X, and that's Y. Make sure I didn't do something foolish in the set position. Maybe something to do with my drawing is not working. Extremely frustrating. Alright, pause the recording for a minute, and I think I actually figured the stupid problem out. Everything was working good. But this right here is unfortunate. You see how I put the F here? I wasn't calling in the correct element, so these are problems you'll really run into. Now, when we use the get shape, I put I, that way we can get the one in the correct element. I may have to use an arrow on this, maybe not. We'll see if this runs. Oh, and there we go. You can see we need a couple more. We'll change floor count, let's say 28. Not enough. It's fine with me. 32. I'm not too worried about using too much memory, making it exact. There we go. And now we just gotta get our player on the right level. That was such a stupid mistake, but stuff like that just happens in development when you're coding if you're not careful. Alright, so now we need to put our player on the right level. The player is going to go on, let's see, what's 1015? We'll pull up in our calculator because I don't like doing math in my head. Let's see, 1015 minus 65 because of the outline, that'll be 950. Alright, so we'll just go ahead and set this for 950. See how that looks? That should fit perfect. And it does, directly on the line. Alright, and now we don't even need this little debug code anywhere. That's how you can debug to make sure code's running properly. Now we have that, we need to go into our player method, our update function. And what we'll do here is we'll just easily say if, because you can currently make the player go off the screen, we'll say if m plus dot x is less than 0, then m plus dot x equals 0. That'll clamp it to the screen, and you can also do the same with like if mpos dot x is, let's see, greater than, trying to figure out because the sprite is on the left, it starts at the top left hand corner. Let's see, I think it would be 1920 minus 65 is greater than 1855, then mpos dot x is equal to 1855. I think that should keep our sprite locked onto the screen. Yep, he's locked on that side. Locked on that side, so now you don't have to worry about your sprite going off the screen in this tutorial here. Alright, now the only other thing we really got to worry about is getting some projectiles up and going now. Now that we got that taken care of, we'll create a projectile class. This should be fun, and hopefully it doesn't give us any more problems. So we'll right click, add class, projectile, and this stuff can all be done using shapes. As I said earlier, we're just doing this, you know, just doing rectangle or using sprites. We're just doing rectangle shapes because it's easier to get the tutorial up and going. We're going to include our SFML graphics as usual. Go ahead and create our public and our private. Now, we're here in public. This is going to be a little bit different. Also on this, we're going to include, this is going to be fun, we're going to include random. That way we can create a random device. STD random device. We're going to name it RD. Also, I'm going to put that in public. Alright, and on private, we're going to need to put in a rectangle shape. And we'll name it M shape. What else do we need? Vector 2F, M pause. And now everything else I think can be done in the constructor that we're going to do. So let's type in, make the constructor like that, and then let's also add an update function, which is going to take in a SF time DT, and that's going to be void in front of it. Oh yeah, well, what did we do wrong? We did something wrong. I think it's just the way we did it. Alright. Put it with a capital, it's working fine now. Alright. Now we'll go to our floor CPP. Not floor CPP, excuse me. I know why there might be a few errors. Also, I gotta put this in my right folder with my other files. Alright. Now I can open up my projectile. I'm going to close some of these files I'm not using at the moment. Now we got our projectile. That's CPP. Alright. Let's type in projectile. Projectile. Alright, so we got our constructor here. If we can hit the right key, we can't do that at all tonight, apparently. We'll say impos, or because we got random. Matter of fact, we'll put that in like the update function. So in the right now, all we'll do is we'll type in the M shape dot, let's see, set size. We're gonna set these to a little bit smaller, and I guess we gotta use a vector 2F, SF vector 2F. We're gonna make these 32 by 32. M shape dot set fill color, SF color to, it can really be anything you want. We're gonna set it to yellow is kind of ugly. We'll set to cyan, because why not? You can always change it. If you don't like it, you can set any color you want. Alright, so we get its size and we get its fill color, and then let's see, shape dot set outline thickness to 1, and M shape dot set outline color. We're gonna set it to white. Alright. Now we'll do projectile. Update. Subtime DT. Why do I keep missing that key? I never do that. Because it's not, I have to put a void in front of this, that's why. There we go. Yeah, let's make sure I got everything. We're also going to need in private, we're going to need a float fall speed. We're going to set this equal to about 600, because why not? Alright, so now we'll do impos. dot x plus, let's see, yeah. Actually, I'm not even going to worry about implies dot x. We'll handle that later. We'll do the implies dot y. Also, what we'll do at the very beginning is we'll set the position to like negative 5,000. You'll see why I'm doing this. I'm just getting it far away from the map. Negative 5,000, negative 5,000 on the constructor. Alright, so we'll do this. Implies.y minus equal, or actually falling, because in SFML, the top of the screen is 0, and the further you go down, it's larger. I know it sounds weird. You'd think it'd be the other way around. But so we'll plus equals m, what did I name it? Fall speed. We'll also multiply that times dt dot s seconds. And this is where the fun begins. We'll say if implies dot y is greater than, let's say, the screen size is going to be 1920 by 1080. So 1080, so we'll put 1090, so this way we see it. Actually, I'll put it as 1100, just so you see it go off the screen completely. Then we'll do our random device that I was talking about. So now we'll type in std uniform int distribution. Trying to remember exactly the code on how to do this. Alright, so we'll set this y between, we don't want it to be at 0, we want it to at least be about, the tile itself is going to be 32, so we want this number here to be, I don't know why I named it dt, y spline is what I'll name it. We want the y spline to be between negative 35, we're picking a number, or no, negative 32, and negative 64. And now we'll do this again. So that's how this is basically going to give us a number between negative 32 and negative 64. And now we need to create another one of these for the X spawn, and we want this to be between 0 and where's our calculator? All the way to the right was 1080. I forget because we used those are only gonna be about 33. I mean, because we did an outline on them. All right, so we'll do 1080. Or no, it's 1920 is the X. So we'll go ahead minus 33, 1887. Between 1887. Alright, then we'll do implies.x equals x spawn And then like when you have trouble, you know, you just pull up some documentation. Make sure I'm doing this right. Alright, so we have our type of int here. Alright. Oh well. The documentation, I'll like sifting from it. I did this on an earlier project. So while we wait, I'll see how I did this exactly before. I see. Alright, so our random device is how we plug it in. And that's the importance of looking up documentation. And now, with this bit right here, basically now we're able to set our spawn there if it goes below the edge of the map. And we're able to set our y between -33 and -64, and our x between 0 and 1887. And you could also get a little bit tricky with it here. We'll do one more. We'll type in int. We'll call this falling speed, and we'll set it between what do we have it set for on here? 600. We'll set this between 500 and 800. And then we can say falling speed, or fall speed equals falling speed RD. Alright. Now after we get our stuff drawn in our update function, we should be good. And also put if it's greater than that, then that should happen. Alright, so we'll just set our y, because that's the condition to update it and change its position. So we'll just set this to like 10,000. Alright, now we're back in our main function. We need to go ahead and include our projectile class. We'll create projectile. We'll just name it proj. And now we'll let me see where I did this. We're going to create a constant integer called proj count. We're going to set it to like 15. Alright, so now we have 15 projectiles in a array here. and I don't have to worry about setting the position because our update function is going to do that on that one. So now all I need to do is worry about the draw. I know the floor ain't going anywhere, so let's go ahead and put it here for int I equals 0 if I is less than proj count I plus plus. We'll do window dot draw. We are going to have a setter though. A getter function, so we'll type in SF rectangle shape, get shape. SF rectangle shape. Projectile, get shape. Now we'll just return the shape, that way we can draw it. Okay, so now we'll return proj I dot get shape. Now if I'm not an idiot, I'm thinking it's not gonna work. I didn't do the update on it. At least I caught it. I'm not sure if this would actually work this way. Probably not. I'm pretty sure this won't work, but I'm just doing it for curiosity. That's how you learn as you play around. Oh, it definitely won't work. It threw an error. Alright. So what I will do though is we will update it in here. Why not? Why not update it right before it's drawn? Try that again. I did something wrong. Let me make sure I have the fall speed working right. I do. Alright, alright. Now we'll see if this works. Definitely not gonna work. Alright, so we definitely know it's the update function. although this is a huge issue. Alright guys, after a little bit of waiting, I found out what the error was. So pretty foolish error. I made a lot of errors in this video, but I showed you how to fix errors if you found them. Alright, so if you go to your projectile script, what you're going to see here was I changed this for testing purposes. When I was using the negative numbers, I accidentally put the larger number up front because of negatives, so I put negative 32 and negative 64, something like that here. So the 64 is the smallest number, so it should go in front, and then negative 32 should go on the right side. And then also this mShape.setPosition should go under this if statement. That way it's drawn every frame and not or set in the position of the sprite every frame, not only if it's only, you know, greater than 1100. So after you get that done, you can hit play, and as you'll see now, it works. And also I'll show you one more change I did. Don't need that debug log, that takes up resources in the main function. I thought that the problem was originally I split this code up, but I actually don't think that I even need to split the code up, so now there's no need for me to run this twice. But you know, I have the get shape and the project. That's actually the wrong thing to split up. Alright, that's the wrong thing, ignore that. Alright, so right here for the projectile update, I'd put that in a separate one, but I don't think that that's going to need to be the case now. Try to optimize this and keep it in one for loop. So we have our update function on I to update that projectile, and then we draw it here. Alright, and now as you can see, we have projectiles of different sizes running back and forth. And you can do all sorts of stuff from here. This is pretty much the game, but let's say you want to close the game when the player gets hit. What we'll do here is, one way of doing this is we'll go to our projectile script, or actually we'll go to our projectile script. We'll handle it on the projectile. So on our update function, we'll have it take in this one. We're also going to include our player file. Alright, so now in our update function, we'll put player P, and we'll also have it take in an SF window, and we'll call it window, because this is just what I'm going to do with it. You can do whatever you want, and show you kind of how you can add your own mechanics, where if you wanted to have like a score system set up and whatnot, anything like that, you could do that as well. Alright, so now in the update function, we have our time, we have our player, and we have our SF window. Alright, so now what I'll just say is, if mShape dot get global bounds dot intersects, we're going to type in P, we're also going to have to add one more function to our player, unfortunately. Not really unfortunately, it's good to get practice. Alright, so we'll type in void, or no, SF float rect get bounds, and that's in our player header file. Now we'll go to our player function, we'll type in SF float rect player get bounds, and now we're just going to return mShape.get global bounds. Now that we have that implemented, we can go to our projectile C++ file. Alright, we'll say if it intersects p.getBounds. Then we'll take in our window and we'll close it. That's just what I'm doing. Now if we go back into our main function here, We have our time, and we'll pass in our player. It says here in the little notes you can see underneath, is how it takes a time function, a player function, and a window function, or a window object, I mean. That is unfortunate. Let's see if I can figure out a way around this. It says apparently it does not want me to take a window variable though. Said it cannot be called implicitly. Wonder if I can put a reference to it. Where's it at? Projectile. We'll try to tell it to take a reference. Sometimes they'll say something will work and then sometimes it won't. That's unfortunate. But there's other ways around, so you can see that, like, let's say for some reason you can't do something like this. There's always other options of making stuff like this work. It's always good to get practice. Alright, so we'll do something else in our player function. Alright, so we'll have player. We'll just add one more public function called int lives equals 1. That's what we'll do for now. Where are we at? Where are we at on this? Alright. So now we'll go p.lives minus minus. Now we'll go into main on the update function and we'll say if proj dot if won't need it there. And also what we'll do to get a little more performance, you notice we'll actually reference the player. That would be really helpful. Alright, so we'll call this as a reference. Alright. Now that we got that, we'll go back to main, now that it's a reference to P. And now I'll say in the update, I'll say if p.lives is less than 1, because that's just how many lives I'm getting, and I'll say window.close. Now we'll test this. This is another way around, and there's more ways you can do stuff. And there we go. That's how I did it here. I hope you guys enjoyed the video. If you found it helpful, I'll try to bring you guys more videos. Sorry it's so rushed and not really thought out, kind of doing everything on the spot because I'm so busy. But if you guys enjoyed this, hit the like button, comment below, and I'll try to bring you guys some more tutorials. Alright, thank you guys and see you next time. FFdev out.